Hello, hello, hello. It's Mr. Pouts, and I'm going to go through the Unit 1 Mid-Assessment Review with you. This should say review at the top of yours. This is a study tool for you to use in advance of the unit assessment that's coming up. So I'm just going to go through problem by problem. You can follow along. Hopefully that'll answer some of your questions if you had any, and clear up any things that you were struggling with when you went through it yourself. All right? Use it as a resource. So let's start with number 1 right away. Number 1 says Tasha's bedroom is shaped like a square. So remember, a square is a 2D shape where all 4 sides are the same length. So the length and width are the same length. The room has an area of 169 feet squared. That's what it says in there. Sorry, that's kind of unclear. What is the length of one side of Tasha's bedroom? So think about area. We know area is length times width. But for a square, if both the sides are the same, area is just x times x, or x squared. So you can just multiply one side by itself to get the area. Now in this problem, we specifically know that the area is 169, so we can put that in. We can plug it in for the a. And we have 169 equals x squared. Now we learned if you have x squared, we can do the inverse to figure out what x is, and the inverse of squaring something is the square root. So x would be equal to the square root of 169, and the square root of 169 is 13. So my answer for this question, if I'm trying to find one of the lengths of the sides, that would be x. So one length of the side is 13 feet. Not feet squared, because it's not the area, it's just a length. Sorry, that should go in the box right there. Okay? That is number 1. All right, number 2, we're going to jump around. Here's a question on exponents. So if you want to pull out your exponent properties sheet, that's helpful. If you notice in number 2, there is an exponent outside of parentheses and there's only one base. There's a base of 3, and that's on the inside. So this is the power to a power rule, where you take the outside exponent and multiply it by the inside one. So we would have 3 to the 2 times 5 power, which is 3 to the 10th power, and that would be letter C. All right, make sure you're showing all that work. Number 3, consider the number 0.19 repeating. Part A, write it as a fraction. Okay, so we talked about this. If it was not repeating, it'd be 19 over 100. But since it's repeating, and that is in the hundredths place, for repeating decimals, we want to do the hundredths place, so 100 minus 1, and I get 99 as the denominator. And then our numerator is 19. So that's our denominator, so we can put 19 on top, and there's our fraction. 19 over 99. Check it on a calculator. It should get you 0.19 repeating. Now, part B says, is 0.19 repeating rational or irrational? Now that we wrote that as a fraction, my hope is that is really easy to answer. Remember, rational is fractional, so it is rational. And the reason you can say is because it can be written as a fraction. Remember, anything you can write as a fraction is going to be rational. And those things include terminating decimals, repeating decimals, fractions, any integers, whole numbers, or natural numbers as well. All right, turn to page number 4. A cube-shaped planter has a volume. So again, a cube is just like a square, but it's 3-dimensional. But same idea, all the side lengths are the same. And that includes the length, the width, and the height. They're all the same. And this one says well, actually, before we get to that, it's a cube. So volume of a cube is length times width times height. Or in this case, since they're all the same, It's x times x times x. So volume is x times x times x, or x cubed. And in this case, our volume is 729 inches cubed. Let's plug it in for the v. So it's 729 equals x cubed. What is the length of the planter? Meaning, what is one side length? What does x equal? So to get x all by itself, we do the inverse of cubing something, which would be cube rooting it. Cube rooting 729. Okay. If you need help to finding the cube root, I will pull up in my calculator here. I think my calculator has cube roots. I hope it does. Let's make it so that it actually fits on the screen here. Mine does not have a cube root on it. But a lot of calculators, you hit the second button and then you hit the caret button, the little rooftop button, after you put a 3 in. And you should be able to do the cube root. So it goes 3, and it should look like 3. And then on your calculator, it's got a little x root, and then you type in 729. It should end up equaling, I believe, it's 9. So the cube root of 729 is 9. And that means our answer, our side length, is 9 inches. All right, let's go to number 5. Number 5 has 4 parts to it. We want to figure out if each one is true, which means if there's any time we have to simplify something, let's simplify it. So we're going to simplify this part first for this one, because we want to see if it's equal to 2 to the 14th power. So 2 to the 9th over 2 to the negative 5th, we're going to subtract the exponents, so it would be 9 minus negative 5. Minus a negative turns into positive, which would be 9 to the 14th power. And it shouldn't be 9, it should be 2. 2 to the 14th power. Alright, so that is true. It works out. If you look at letter B, we want to simplify the part 5 to the 0 power to the 3rd power. Anytime you have an exponent on the outside, we multiply. So we're going to take this and multiply. 0 times 3 is 0. So 0 times 3 is 0. Anything times 0 is 0. So 5 to the 0 power. Anything to the 0 power is 1. So that does not equal 5 to the 3rd, so that's false. All right, let's look at C. We got to simplify the left side again. 4 to the 5th times 2 to the 5th power. This is that no-name property that we dealt with, where they have the same exponent but not the same base. So if we want to simplify that one, we can multiply the two bases together and keep the exponent. So that ends up being 8 to the 5th power, and that is not true. They said 8 to the 10th power. All right, last one. Let's simplify this side on the left again. So 3 to the negative 9th power times 3 to the 7th power. That's where you have the same base, so you keep the base and you add the exponents. Negative 9 plus 7 is negative 2, so we get 3 to the negative 2nd power. Now just think, you can't have a negative exponent. What do? Let's change levels. Move it to the bottom. It becomes a positive exponent, and you leave 1 on top. So 1 over 3, 3 squared. And that is true, because that's what they said it was as well. So true, false, false, true. Make sure you show your work. So number 6. Number 6, in a lab, a scientist is growing bacteria for a study. The scientist begins with bacteria population of B number of cells. She discovers that after 2 hours, the population of bacteria is B squared. 2 hours later, the bacteria is B cubed. If the population of bacteria after these 4 hours is 1 million cells, what's the population at the start? So if it's B cubed, and it's equal to 1 million, so B cubed equals 1 million. That's what it said at the end. Can we find what b is? Because b is what it would have started with. Well, let's do the cube root. B would be the cube root of 1 million. The cube root of 1 million, if you type it into your calculator, it's 6 zeros. Should be 100. So my answer would be 100 cells. You do need to explain, and your explanation could be, if you know that it ends up as b cubed and it ends up as 1 million, you can set it equal to b cubed equals 1 million, and then solve it. All right, last one on this page, 12 to the 0 power. Hey, guess what? This is the easiest question on the whole problem, because it equals 1. Anything to the 0 power. That's a 0 power property. Equals 1. All right, turn the page. We got a couple more left. This one is looking at 4 numbers, number 8. Which of these numbers are rational? So we're going to look at which ones are rational. If you type this in, this is going to be, square root of 10 is not going to be rational. So we're going to put that here. That's a never-ending decimal. It's not a perfect square. Square root of, or 3.16, we talked about repeating decimals being rational. So we can explain repeating decimals are rational. You can change that to a fraction. Pi is the classic irrational number, never ending, has no pattern. And then 3.2, that's also rational because you can write them as a fraction. So just remember, writing numbers as fractions, if they can be fractions, they are rational. Now let's estimate each of the 2 irrational numbers. So that's approximately 3.14 and square root of 10. If you estimate it, it's going to be just over the square root of 9, so it's going to be like 3.1-ish. Type it into your calculator, you get about 3.16. Something like that. So that would be slightly bigger than 3.16 repeating. So this one's tricky to do on a number line because they're all so close to each other. So I'm going to go to the hundredths place. We got 3.10, 3.11. And that'll give me, not 4.0, 3.20. That'll give me an easier route for writing these out. So 3.16 repeating, it's going to be just a hair over 3.16. 3.2, that one's an easy one, right on 3.2. Square root of 10 is 3.162, so just a hair above that. So I'm going to say square root of 10. And then 3.14, which is pi, just over 3.14, so that would be pi. All right. Last page. We got the square root of 12. Approximate the square root of 12 to the nearest integer. We don't want it to the nearest tenth or anything like that. Nearest integer. So that's going to be closest to, let's see, the square root of 9 is 3. Square root of 16 is 4. So that is 3 above 9. It's 4 below, so it's closer to here. So we're going to say it's approximately 3. And it's because we use perfect squares. Now we could go farther and still simplify that and try to get more to the nearest tenth in part B. And I would say it's really like right in the middle, but it's just a little bit closer to 3. So maybe approximately equal to 3.4. Again, using the perfect squares. And then it says put it on the number line. If you wanted to estimate that, let's 3.1 all the way up to 4. So 3.2, 3.3, 3.4. And you can check your calculator to see what it actually is. Square root of 12. I get 3.46. So the square root of 12 is like 3.46-ish. So I'm going to say it's right about here. All right, last question. Which expressions are equivalent to 4 to the 12th power? So you need to simplify each one. If I were to simplify a, it is a fraction, same base, so I can subtract the exponents, and I get 4 to the 12th power. A is, if I have same base and they're multiplied together, I add, so 4 to the 3rd plus 4, that gets 4 to the 7th power. That one is not. 4 to the negative 12th, if I rewrite that, I want to change levels. It becomes positive 1 over positive 4 to the positive 12, so that is not the same. If I have an exponent on the outside, that's when I multiply. So I get 4 to the 3 times, or 9 times 3. 9 times 3 is 27, so that is not equal. And lastly, back to one where we multiply, we would add the exponents, and we get 4 to the 12th power. That one is. So that's our review for the mid-unit assessment in Unit 1. Hope that helped. See you next time.